All right, so here is two, day two of systems of linear equations. And just really quick, we're gonna have a word problem. I did want to go over one word problem so that you can see what they look like. And this is a really common one. So you're gonna have somebody's gonna be able to do two things. Okay, in this case, Connor works at a movie rental store earning $8 per hour. Okay, so thing number one. Okay, so you have the first one, and you have the second one. He also walks dogs for $10 per hour on the weekend. So that's the second thing. All right. And notice how it keeps saying per hour. Okay. Per hour on the weekends. Connor worked 13 hours this week and made $110. So how many hours did he work at the movie rental store? How many hours did he walk dogs over the weekend? Okay, so here they're asking for a number of hours. So in that case, we know that hours is going to be the variable. Okay, so hours in the store. Okay, we can let that be X. And then hours with the dogs, walking dogs. So walking hours, we can let that be Y, or let's do W just for fun. Okay, and so what you want to do is usually you're going to just add them. So plus we have X, W, X, W. Okay. And for the first one, usually this is going to be like the like the price, the cost, or the earnings. Okay. So this is going to be the money. All right. So here, how much does he earn at the rental store per hour? $8 per hour. So it's going to be $8 times every hour that he works there. Okay, so 8 times X plus, and then he walks dogs for $10 per hour. So here this is $10 times every hour that he walks dogs. All right, and then it's going to equal, and we have to have two equations. So it equals, here, this is going to be the total. Okay, so the first one is the money. So what's the total money that he made? Total money was 110. That's where that comes in. Now, you're probably wondering, what about the second equation? So notice that the second equation, they gave us another number here that doesn't really fit into that equation. The second number is he worked 13 hours. Okay, so because he worked 13 hours, we need to put 13 hours here. So the second equation is usually like the sum of the times or something. The sum of the two together equals the total. Okay, so money and time, or hours if you want. So you're adding how many hours he worked in the store and how many hours he worked as a walker. And when you add those two together, you should get 13. Okay, and here you're finding out how much he made, right? $8 per hour, how much he made at the store. Here, how much he made walking, and how much he made in total. Okay, and those are your two equations. So you can solve those either way. Graphing, no. Or substitution. Let's do substitution. So for substitution, you want to look for a coefficient of 1. So we have x and w, either one works. So okay, let's solve for x. I'm going to put x equals 13 minus w. All right, so we subtract w on both sides. We'll get solve for x. And that's what we're going to plug in to the other equation. Okay, we're going to plug that into the first equation for x. So the first equation is 8x plus 10w equals 110. So we have 8 times 13 minus w plus 10w equals 110. 8 times 13 is going to give us 104 minus 8 times w is 8w, and then plus 10w equals 110. And then combine like terms, so we have negative 8w plus 10w is going to give us 2w. Plus that 104 equals 110. And then subtract 104 from both sides. Subtract 104, and we'll get 2w equals 110 minus 104 is 6. Divide by 2, we get w equals 3. Ta-da! So that's our first one. W equals 3. So we're going to plug that 3 back into this one. All right. So now we're going to do this one. We have x equals 13 minus our w is 3. And there we get x equals 10. This is 10 hours, and the other one is 3 hours. So he he worked at the movie rental store for 10 hours, and then he worked as a dog walker for 3 hours. That's how you get your answer. Let's put that on the notes. All right, and now we're going to look at our third method, which is elimination. So the elimination method, you'll remember this from Algebra 1 and Algebra 2. You have to multiply one or both equations by a number to result in two equations that contain opposite terms. And the equation eliminating one variable, then solve the equation, substitute to solve for the other variable. Okay. So yeah, that's pretty much it. So the thing that you want to do, the thing I would recommend is to look for one that has a coefficient of 1. So look for a variable that has a coefficient of 1, because that's going to be the easier one to get rid of. Okay. So let's look over here at 14. Let's do one that has, oh, I should mention this. It is best to put them all in standard form. Okay. So put in the form ax plus by equals c. Okay. And yeah, if you could get it like that, that'd be great. And then you want to line up like terms. Notice how all the x's are there, all the y's are there, equals, and then constants. Okay, so look for a coefficient of 1. If you don't have a coefficient of 1, look for a coefficient of -1. Okay, and if you don't have one of those, then it's going to be a little bit trickier, and I'll show you how later, so don't worry. So here, we have a coefficient of 1 with the y's. So what we want to do is we want to multiply multiply that first equation by something that will give us the opposite coefficient of the other y. Okay. So here our coefficients are 7 and 7 and 5 for the x's. And those aren't ones, those aren't opposites. Here you have the coefficient of y is 1, coefficient of the y in the second equation is -1. Hey, look at that. Those are already opposites. So sometimes you already have opposites, and when that's the case, yay, all you have to do is just add them straight down. So we don't have to do much work there. Okay, so when they're opposites, just add them. So add straight down, and 7x plus 5x is going to give us 12x. And then y minus y, we want opposites so that they can cancel out one variable. Because remember, we can solve for one variable with one equation. So 9 plus 15, it's going to give us 24. And then divide by 12, we get x equals 2. Then after you solve for x, okay, so opposite, we have opposites. Check. So add, and then solve for x. And now we're going to substitute it into one equation. You don't need to substitute in both. Just choose one. If you substitute it into either one, it'll give you the same answer. Okay, so choose which one you want to substitute it in. The first one, 7x plus y equals 9, or the second one, 5x minus y equals 15. So I'm going to plug it into the first one. So 7 times 2 plus y equals 9. So 7 times 2 is going to give us 14 plus y equals 9. And then subtract 14 on both sides. You get -5. Ta-da! And that's our answer. 2, comma, -5. Remember, always x, comma, y. All right, and if you plugged it into the 5x, you get the same thing. 5 times 2 minus y equals 15. You get 10 minus y equals 15. Subtract 10, you get -y equals 5. And then take the negative of both, make it a positive y, and you get y equals -5. So it doesn't matter which one you plug it into. You should get the same, okay? Because that's where the two lines are meeting. That's that. Okay, so let me show you one where we don't have any coefficient of 1. So number 15, yeah, it looks good. Let's look at number 15. So here we don't have a coefficient of 1. Our coefficients are 2 and 4 for the x's. And for the y's, we have -3 and -5. Oh, no. So what we want to do is you can multiply by, if you want to do it the nice, clean way, okay, you want to multiply by um, uh, a common multiple. You want to get a common multiple, okay, out of each. So uh, you want to get a common multiple of 2 and 4, or get a common multiple of -3 and -5. Okay. So the best thing to do is you might see the 2 and the 4 and you say, hey, yeah, that'll work. So you can just multiply this top one by 2, right? Or in this case, a -2, so we can make it opposites. Okay. So you want opposite signs. So 2 times 2 is going to give us 4, and then a negative would make it -4. Okay, there's that. Then you can distribute, and you only get -4 plus 6. And there you go. Okay, so we could do it that way. There's another way if you don't want to, if you can't think of any multiples, common multiples, easy thing to do is to multiply it by the other coefficient. So for example, we have 2 here, we have 4 here. So for this one, you would multiply by the other coefficient, which is 4. And for this one, you would multiply by the other coefficient, which is 2. Okay, that's it. And then when you do, you'll end up with the top one becomes, oh, and one of them should be negative. Let's make this negative. Why not? So this will become -8, and this is going to be +12. And down here we have 8, +8, and -10. Okay, so there we get opposites as well. So this is the one if you don't want to think about it too much, just multiply by the other coefficient and make one of them, make sure they're opposites. So you might have to multiply by a negative. However, uh, it will give you bigger numbers, potentially. Okay, if there's no smaller number to multiply, there's no smaller multiple. So you could get bigger numbers, okay, which isn't too bad. So there you go. Okay, that's the one that I would recommend if you can't think of any multiples. All right, but here we have a multiple. We can multiply this one by 2. And not just 2, but -2, because we want it to be the opposite of 4. So multiply the top by -2, and we get -2, sorry, -4x. -2 times -3 is +6y. -2 times 1 is -2. And the second equation didn't change at all. All right, we have opposites. So now we're going to, oh, so get opposites, and then all right, and now we have opposites. Yay. All right, so now we're going to add So let's add straight down. So here, negative 4x plus 4x cancels out. And we're left with 6y minus 5y is 1y. And now we just have one variable. And negative 2 plus 7 is 5. And there, now we're going to plug that in to either one. Okay. So either the 2x minus 3y equals 1 or the 4x minus 5y. And I'll just plug in the first one just because. 2x minus 3y is 1. So 2x minus 3 times 5 equals 1. And we get 2x minus 15 equals 1. Add 15 to both sides. You get 2x equals 16. Divide by 2. You get x equals 8. And that's it. Yeah. So there's our answer. X, then y. Ta-da! And you could plug it in to check if you want. Okay. So to check, you don't have to do this if you don't want to, but if it asks you to. So you just plug in the x where you have the x and the y wherever you have a y. So 2 times 8 minus 3 times 5. All right. The 2 times 8 is 16. Minus 3 times 5 is 15. So we get 1. Yay. And then here, 4 times x is 8. Minus 5 times y is 5. So you get 32 minus 25 gives us 7. Yay. So it's correct. Okay, that's how you can check. And that's it. And let's look at some more of those problems if you'd like. Actually, I think that's good. Are there any others that you want to look at? Let's check. That's okay. No, they're all okay. So yeah. So they're all going to be pretty much the same. There you go. And now we're going to have the big one. So we only have 8 minutes. This is a solving systems of equations in 3 variables. This is going to be interesting. Okay, so we have x, y, and z. So these take a bit of time. All right, so you want to do it the same way. Eliminate one variable at a time. And then you're going to end up with 2 equations. Okay, so let's try it out. All right. So here, let's look at 20. For this one, you want to definitely look for one that has a coefficient of 1 right there. Okay, so first thing that we're going to do is we're going to use these two. Okay. So I'm going to call this row 1, row 2, and row 3. I'm going to do row 1 and row 2. And what I'm going to do is I'm going to I'm going to try to cancel out an x, y, or z. Now, which one am I going to cancel out? I'm going to cancel out the x because I have a coefficient of 1, and it's easiest. Okay, so what I'm going to do is I'm going to multiply row 1 by -3 to get an opposite of +3, because -3 times 1 is -3, which is going to get us the opposite and cancel out the x. And then I'm going to add that to row 2. So let's try it. So -3 times x plus 2y plus 3z equals 5. We get -3x minus 6y minus 9z equals -15. There we have 3x plus 2y minus 2z equals -13. That's row 2, and just add those two together. You add them together, the x's cancel out, which is what we wanted. -6y plus 2y is -4y. -9 minus 2z is -11z equals -28. That's all we can do for now. Now we're going to get another equation with just two variables. Okay, so we're going to use row 1 again. That's our special equation that has a coefficient of 1. So row 1, and we're going to combine it this time. Instead of row 2, we're going to combine it with row 3. All right, so look at the coefficients. Our coefficient of x is 5. What's the opposite of 5? -5. So we're going to multiply that row 1 by -5, and then we're going to add those two together. So we have -5 times x plus 2y plus 3z equals 5, close parentheses. We get -5x minus 10y. -5 times 3 is -15. Z equals -25. And row 3 is 5x plus 3y minus z equals -11. So let's add those two together. The x's cancel out, and we have -7y. -15 minus 1z is going to give us -16z. And -25 minus 11 is going to give us -36. All right, so now we have two. Oh, I should have made this a different color. Ooh. Oh well. So we have -4y minus 11z equals -28, and -7y minus 16z equals -36. Okay, so does -4 and -7 have anything in common? Like, can we get a small multiple? Not really. -11, -16, definitely no. So the smaller one that we're going to get is the 4 and the 7. So what we're going to do is we're going to do this multiply by the other coefficient. So here, we're going to multiply this top one by 7. Okay. And we're going to multiply the bottom one by 4. Okay, but remember they're both negative, so one of them has to be a different sign. Let's change this one to a negative, the top one. And when we do, we end up with 28y plus 77z equals 196. You can check my work there if you'd like. I would if I was you. And 4 times -7, -28y. There you go, opposites. 4 times negative 16, negative 64. Z equals negative 144. Yeah, looks good. All right, now we're going to add them. So let's add those. These cancel out. We're left with 13z equals 52. Divide by 13, z equals 4. Yay, we got 1. Now we're going to plug that in to one of these equations. Okay, which one are we going to plug it into? Probably that first one, smaller. So negative 4y minus 11z equals negative 28. We have negative 4y minus 11 times 4 equals negative 28. Then we get negative 4y minus 44 equals negative 28. Add 44 to both sides. And you get 16. Divide by negative 4, we get negative 4. Ta-da! And we get our y. Yay! So when you have two variables, two answers, the next part is easy. You just plug those into one of the original equations. You plug it into here, here, or here. Which one am I going to plug it into? The easy one, row 1. So row 1 is x plus 2y plus 3z equals 5. So x plus 2 times negative 4 plus 3 times 4 is 5. Almost done. Negative 4, 4. There you get x minus 8 plus 12 equals 5. You get x plus 4 equals 5. Subtract 4, we get x equals 1. And there we go. So for 3, it's going to be x, y, z. Always goes in order. So 1, negative 4, and 4. And that's it. So feel free to try those other ones and see how it goes.